Octopuses are brainiacs. We have seen them open jars and even predict the outcome of soccer matches back in the day. That one was a fluke, but they are clever creatures. Case in point, octopuses in the wild are capable of gathering posses of fish to go hunting for them, and if the fish don't want to cooperate, researchers caught the octopus's response on video. Keep watching to see what happens next. Meet Dave. Dave is a day octopus. Dave, like other octopuses, is very smart. If you try to come up with examples of clever animals, you might think of primates or crows or dolphins, but if you only come up with vertebrate animals, the cephalopods would like to know your location. When looking at the ratio of brain size to body size, cephalopods, including octopuses, fall in the same range as most vertebrates and have a much higher brain to body ratio compared to their fellow invertebrates. In this case, bigger certainly is better. Octopuses use these large, complicated nervous systems to perform some really neat behaviors. Perhaps the best known is their ability to camouflage. This requires taking an incredible amount of information about the world around them, processing that, and sending out neural signals throughout their body to change both the color and the texture of their skin to hide better. Octopuses also seem to be able to solve complex problems and learn. They use the suckers on their tentacles to pry open hard-shelled foods and are able to figure out how to open lidded jars to get to the yummy octopus snacks inside. There's even evidence that some octopuses can learn just by watching another octopus complete a task. So we know that octopuses are smart. And they're also very food motivated, which brings us back to Dave. Like most octopuses, Dave typically lives alone. Yet here he is, hanging out with a bunch of other fish. What are you up to there, Dave? Not only is our allegedly solitary Dave hanging out with these fish, it turns out he is hunting with them. The main characters that can be seen hanging out with Dave are blue and yellow goatfishes and blacktip groupers. Dave and the fish all like to munch on the same sorts of food, including smaller fish, crustaceans, and mollusks. So cooperation could benefit them all. As the fish are exploring around to find prey, they signal Dave that there's some good food underneath a specific rock, and then Dave comes over and envelops the rock with his body to trap whatever is underneath as a tasty snack. In this process, some prey often escape for the fish to munch on as well, so all parties are benefiting here. Dave gets good intel about where the food is so that he has to make fewer feeding attempts, and his fishy friends get the leftovers from whatever he doesn't catch. We'll see how they work together in a second, but first, we need to keep the lights on.
This SciShow video is supported by Jump, a statistical analysis software that makes powerful analytics quick and accessible. Like, financially accessible. The new Jump Marketplace lets you download pre-made applications, add-ins, data connectors, and other Jump extensions all for free. And that means you can customize the software to suit your needs without doing any coding of your own. Why spend time reinventing the wheel when somebody else has already built the solution that you need? But of course, if you do like to dabble in your own code, you can do a ton with Jump's scripting to automate repeat analysis. And the workflow builder lets you share processes with colleagues so that you can standardize best practices and boost reproducibility. You can check it all out at jmp.com/scishow to see the benefits of visual statistics for yourself. And Jump offers a 30-day free trial for anyone, anywhere.
So we see why Dave and the other fish are working together, but how do they do it? Well, researchers at the Max Planck Institute of Animal Behavior in Germany spent hours and hours videotaping octopuses to figure out what was going on. We're calling all of these octopuses Dave because it's funnier that way, and also it may or may not be a reference to penguins of Madagascar. It turns out different characters in the group have their own roles to play. The fish are the scouts, and Dave is the decider. The fish venture out to look for the hot new place to eat, and Dave decides whether he wants to go or not. When the fish move to a new spot and Dave follows, the researchers call this pulling. If Dave doesn't follow, the fish will come back. The researchers call this anchoring. From this pattern of movement, it's clear that Dave is calling the shots. But in addition to being the leader, Dave is also a bit of a bully. The goatfish in this group are typically good collaborators, but the blacktip groupers can be a different story. The blacktip groupers are ambush hunters and tend to stop moving when they spot prey, so it's relatively easy to tell when they've got a lead. But sometimes they don't carry their weight. And when that happens, they get punched. And I'm not being metaphorical here. The researchers refer to a tentacle whack as punching in the paper. We're gonna watch that one more time, because I thought it was funny. All right, one more time. Rude, Dave! Let's work on other ways to communicate your frustration. Punching is especially frequent when the goatfish are less prevalent, so more of the crew is made up of blacktips. If the blacktips aren't doing much, Dave will just start punching them to tell them to get back to work, which is like a very toxic work environment. While Dave is being a bit of a jerk, his jerkiness, or leadership, as it is defined by the paper, is enabled by some pretty complex cognition. Leadership in animal groups exists along a spectrum from despotic, like a dictatorship with one animal making decisions, to democratic. Typically, if there is a single leader, the leader will make a decision about where to go, and the group will follow, so leading from the front. Dave, however, is unusual. Dave leads from the middle. His fish minions make suggestions about where to go, and Dave somehow takes in all of that information and makes a decision about whether he wants to go there or not. The rest of the fish follow his lead, even if his lead is just staying put. This behavior is also surprising because Dave is mostly a solitary guy without a lot of social training. Most hunting groups emerge among social animals, where they learn social cues and how to behave in a group from other members of their species. So it's a bit unclear where Dave is learning his skills from. Finally, most groups of animals that hunt together, like wolves or orcas, are groups of the same species. Even within these groups, often this isn't true collaborative hunting, but instead a group of individuals hunting opportunistically at the same time, and if they manage to help each other, that's swell. For hunting to be truly cooperative, different individuals need to assume different roles, like what we see with Dave and his fish pals. This type of division of labor has been observed in some multi-species assemblages of hunting groups, notably moray eels and groupers. But even then, the group dynamics of the moray eels and grouper are simpler than how Dave influences the fish. When groupers are hungry, they will signal to a moray eel, and the eel will join the grouper on the hunt. Each one uses different hunting strategies to force their prey into the mouth of one or the other. Groupers hunt in open water, while morays hunt among the rock crevices, so between the two of them, there isn't really a place to hide. But when the groupers or the morays are disappointed in each other's work, there's no negative feedback mechanism, unlike Dave, who, as we have seen, makes his displeasure known. Dave is out here overcoming the odds of his antisocial upbringing, bossing around other fish and making it known when he is not happy with their performance. That is some seriously high-level cognition. I, for one, welcome our new cephalopod overlords.